Good day, students. I hope everybody is doing great. Our main strands today is number. Our substrands is fractions. And under the fraction, we are going to talk about equivalent fractions. So you will talk much about the fractions, how fractions looks like, and how two fractions are said to be equivalent. Okay, good. Equivalent fraction. When you talk about equivalent fractions, before then, let's know the meaning of fractions. A fraction is a part of a whole or a part of a unit or a number that represents a whole that has been divided into equal parts. So we have two parts of a fractions. We have the numerator and then the denominator. When you talk about the numerator, we are referring to the taking parts of a fraction. When you divide a whole or you divide a unit or you divide one, the taking portion, we call it numerator. And then the denominator is the division part of a fraction. So that's the difference between the numerator and denominator. Numerator is always found at the top of the division bar, while denominator is always below the division bar. Okay, good. When we talk about equivalent fraction, equivalent means equal value fractions, equal value fraction. That is the word that we derive from equivalent, equal value. So when we say equivalent fraction, which means that a fraction that can be defined as or can also be defined as fraction with different numerators and different denominators that represent the same value or proportion of the whole. You might have two fractions with different numerator or different denominators, but the weights of the fractions are the same. When you talk about the weight here, I'm referring to the real value of the fractions or the value of the fractions are the same. Though they might be different numerators and different denominators. So equivalent fractions means equal value fractions. So fraction with different numerator and different denominators, but they have the same value or the same proportion of the whole. Okay, good. Let me demonstrate one or two things that shows what equivalent fraction to you. Let's assume that a teacher dashed into a class and then the first person of the row, he gave the person a 1 Ghana cedi paper. The next person, he gave that person 2 of 50 pesos to the person. And then the next person again, the third one, he gave the person 5 of 20 pesos to hold. And then the fourth person, he gave the fourth person 10 of 10 pesos of our currency to hold. Now, per the amount stated here, the first person was given 1 Ghana cedi paper. The next person was given 250 pesos. The third person was given 5 of 20 pesos. And then the fourth person was also given 10 of 10 pesos. Though the currency notes, they are not the same. The quantity of some coins are more than the other, but the value of the money given to the 4 people are the same. What 1 Ghana cedi can do, the person holding the 2 of 50 pesos can use it to buy, or the person using the 5 of 20 pesos can also use to buy a thing that costs 1 Ghana cedi, or can also be used to establish the cost of 1 Ghana cedi, or the person also using the 10 of 10 pesos can also use it to buy anything that costs 1 Ghana cedi. Though the quantities wasn't the same, but the value is still 1 Ghana cedi. That is equal value. Though the denominations, some coins are in different quantity, but the value of each amount given is the same. Okay, good. Let me quickly solve one more example and then we move on. Let's see how to derive our equivalent fractions, or how to check our equivalent fractions here. Now we have 4 units of mango or orange. Okay, each orange here represents a unit, or a whole, or an orange. Okay, and it is 1. And we said a fraction is a part of a unit. So a fraction can be part of 1 orange. So when you take part of the orange, that one we call it fraction, because part of only 1 orange has been taken, and the one taken is a part of a whole. The whole represents 1. Okay, now we have 4 oranges here. We are going to check how to derive our equivalent fractions from these 2 or 4 ranges here. Good. Now with the first orange here, a person may decide to divide this orange into 2 equal parts. Okay, and then decided to choose the half of it here. Okay, good, which represents 1 taken here out of the 2. Okay, so here the orange, it has been divided into 2 equal parts, but only 1 has been taken. Therefore, we call it 1 out of 2, or 1 over 2, or half. Okay, good. Somebody, the second orange, somebody may also decided to divide this orange in this part. Okay, and then decided to take 2. Therefore, the orange here, it has been divided into 4 equal parts. And the person has taken 2, which is 2 out of 4. Okay. So the first orange, we saw that the orange was divided into 2 equal parts, and he took 1. He took half of it, and that one we call it half. The same thing, another orange was divided into 4 equal parts here, and he took 2, which means that the half also remained. Okay. The third orange here can also be divided into this equal parts here. Then, if the person decided to take 3 out of 6, now this orange here has been divided into 6 equal parts, and the taking part is 3 out of 6, which also represents half of the orange. So the numerator here is a 3, the taking part of the orange, and the denominator, which is the division part of the orange. Though the orange is divided into 6 equal parts and 3 has been taken out. That means the other half, or the remaining 3 over there, represent the half of the orange. Okay, good. Now the third one here, person may also decided to divide this orange into 8 equal parts. Okay. Then decided to take 4 out of the 8. Then, which also represent the half. Though the orange though the 4 oranges here are not divided in the same proportion, but the values of the orange left are the same here. Okay, so when the person decided to take the 4 out of 8, which also represent the half of the orange. Okay, so here the orange was divided into 8 equal parts, and 4 has been taken, okay, which also represent the half of the orange. Are you okay? Good. So though the first one is 1/2, the second orange here also represent the 2 out of 4. They have different numerator, which is 1 against the 2, and different denominator, which is 2 against the 4. Therefore, because they are all different fractions here, but looking at the values of the orange, the first one represent the half because only part of the 2 has been taken, or 1 has been taken from the 2. And looking at the second orange here, the second orange also talk about the 2 which have been taken from the 4, because the one orange here is divided into 4 equal parts and 2 has been taken from them, and therefore which also represents the half. Okay, good. Now looking at this kind of orange here, the third one was also divided into 6 equal parts, and within the 6, the 3 also been taken out of the 6. And you know, when you have 6 and you took 3, which also represent f, okay, also represent the half of the orange. Okay, so this side also represent the half of the orange. And then looking at the fourth orange here, the fourth one to is also divided into 8 equal parts. These 8 equal parts here, and the 4 out of the 8 has been also been taken out. So the remaining one here also represent the half, because when you have 8 and you took 4, it means half has been taken, okay, which means that half have been taken. Though they are all different fractions here, they have different numerators, which is 1, 2, 3, and 4. Different numerators and different denominators, which is 2, 4, 6, 8. But the values or the size of the oranges are all the same. Okay, good. Which means here, these fractions here are equivalent. 1/2 is equivalent to 2/4. 2/4 is also equivalent to 3/6. 3/6 is also equivalent to what? 4/8. 1/2 can also be equivalent to 3/6 and 4/8. So this is how equivalent fractions looks like. Fractions may be different, but emu weight and also emu draw nyinaa ɛyɛ pɛ. Ne nyinaa represent half, but though kwan yɛfa so kyikyɛ mu no ɛnyɛ pɛ. And that doesn't mean that fraction can never be equal. They are equal. Let's work one more two things here to prove beyond doubt whether the fraction that we have here is equal. Okay, good. Now, when we take 1/2 here, and if you want to know whether 1/2 is equal to 2/4, then the only thing that you have to do is that you check their denominators. Now, upon all the demonstration here, and you are still doubting whether these 4 fractions here are not the same, so we want to know whether these fractions here are equal, okay? Then the only thing that you have to do is that you check their denominators. And when you check their denominators, here is the 2 and here is the 4. So from the 2 to 4, what number do you think when you multiply by the 2? That will be 4. The same number must be used to multiply what? The numerator, so that you know how the equivalent fractions looks like. So we realize that when you multiply 2 by the 2 here, it will be equal to the 4. Then the same number that you use to multiply the numerator must be used to multiply the denominator, okay? Or the number that you use to multiply the denominator must also be used to multiply the numerator. Now, when you multiply the 2 by 1, then you get a 2. 2 by 2, you get a 4. This is how the equivalent fractions look. So when they ask you to write equivalent for any other fractions, the only thing that you do is that you choose any number, but you make sure the number will be used to multiply the denominator first, and the same number must also be used to multiply what? The numerator. Then you get equivalent. Okay. Now let's assume that the question is 1 out of 2, and they ask you to write another or state another equivalent fraction or another fractions that looks different from 1 over 2, but the values are the same. Then you can also pick up the 3 and number 3 to multiply the denominator here, okay? And then the same 3 must also be used to multiply the numerator, and let's see what we get here. 3 times 1 will give you what? 3, and then 2 times 3 will give you what? 6, which means that 3 over 6 is equal to 1 over 2. Okay, good. Assuming that you want to write another equivalent fraction for 1 over 2, you can pick up any number like 4. Okay, so use the 4 to multiply the denominator here. And the number that we'll be using to multiply the denominator must be used to multiply the numerator here. In order, so equivalent fraction there, the same number must use twice, used to multiply the numerator, and then use it to multiply the denominator. When you use 1 to multiply the 4 here, you get 4, and you get 4 here. And then when you use the 2 to multiply what? 4 here, that will be 8. Therefore, 8 over 4 is equal to 1 over 2. Okay, good. If you're still doubting, or if you still want a fraction, different fraction with different numerator and different denominator, that will be equal to 1 over 2, then I said you pick any other number, then use the same number to multiply the denominator and at the same time the numerator. So like all what we demonstrate here shows that those fractions here are the same. Or you can also write another number that will be equivalent to 1 over 2. I can also choose a pick up a number like 5, use a 5 to multiply the denominator, use a 5 to multiply the numerator. You will get another equivalent fraction or another fraction that will be equal to 1 over 2. Here is 5 out of what? 10 is also another fraction which is equal to 1 over 2, or another fraction which value is the same as 1 over 2. Or you can also write several fractions that will be equal to 1 over 2. Just pick up any number, counting number, and then you multiply the same number with the numerator and the denominator. Let's assume that I have 3 over 5. When they ask you to write equivalent fraction for 3 over 5, without wasting my time, I'll pick a counting number like 2, because you can't use 1 to multiply numbers, okay? So you start from 2. When you use 1, you still get the same number. So if you choose 2, when you choose 2 here, the same 2 must be used to multiply what? The numerator, and here will be 2. And therefore, when you multiply them, you get what? 6 over 10. So which means that the 6 over 10 is equivalent to 3 over 5. Are you okay? Good. If I want to write another equivalent fraction, that would be, or another fraction that would be equivalent to 3 over 5, then I have my 3 over 5 here. Okay, and therefore I'll pick another number to multiply both numerator and denominator. So here I can also pick 3 to multiply these numbers. Okay, when you pick 3 here, 3 times 3 will give you what? 9. And then 3 times 5 will also give you what? 15. Okay, so which means that the 9 over 3 here is also equivalent to what? 3 over 5. Okay, good. Or if you still doubt, if you want to find out what, you can also use cancellation to reduce the one with different numerator or different denominator to check whether it has the same fraction with the first one, which is the common fraction here. So let's say the 1 over 2 here. We said 1 over 2 is equal to 2 over 4. Let's check. If you want to cancel the 2 over 4 to check whether you still get 1 over 2, then what you choose a common multiple to cancel the both numerator and the denominator. So 2 goes into this one, the numerator here 1, 2 goes into denominator here 2. Now, therefore, we have our 1 over 2 here. So, which means that 1 over 2 is equal to 1 over 2. Now, when you have the 1 over 2, we said 1 over 2 is equal to 3 over 6. If you still doubt they are equivalent, if you still doubt all the equivalent, when you cancel, you still get the same fractions. So, you cancel 3 goes here 1, 3 goes here 2. Okay, so therefore we have 1 out of 2. When you still doubt that 4 out of 8 is equal to 1 over 2, you can still do the cancellation. You cancel the 4, 4 goes here 1, 4 goes here 2. Okay, now we have our 1 over 2. Good. Now, if you're still doubting that 5 out of 10 is equal to 1 over 2, then let's reduce the 5 out of 10 and see whether you still get 1 over 2 here. 5 goes here 1, 5 goes here 2. Okay, therefore we have 1 over 2. Okay, and let's check these fractions too. We said a fraction like 3 over 5 is equal to 6 over 10. If you still doubt, you can also reduce 6 over 10 by cancel them. You see that you get the same fraction like 3 over 5. When you use the 6 and 10, you can use 2 to cancel. 2 goes into 6, 3 here, 2 goes into 10, that is 5. Okay, therefore our simple or common fraction here will be 3 out of what? 5, which is the same as 3 over 5 here. They say we said 9 over 15 is equal to 3 over 5. When they ask you which fraction here is equivalent to this, if you don't know, then just cancel or reduce the one that we said is equivalent, so that whether you get the same fractions as 3 over 5. Now here for the 3 here, you can use the 3 to cancel the 9. 3 goes here 3, 3 cancel 15, 5, and therefore we have our 3 out of 5. Okay, good. So like what you said, equivalent fractions are fractions with different numerators and different denominators, but they have the same value. Okay, or equivalent fraction, I said we derive this word equal value fraction. Okay, good. Now let's solve another situation here. Good. Another example. You have been given uncompleted fraction and they ask you, there's a number here. When you find out, it will be equivalent to 7/8. So there's a number here that will be numerator of what? The 40, which will be the same as what? 7/8. Good. Now let's talk about this side. We have the 4 out of 5. We say 4 out of 5 is equal to a certain number over 20. That will be equivalent. We don't know, you need to find out. Now we have this one. Yes, we said equivalent here. They are all equivalent, but there's a number here. When you put it here, that will be equivalent to 3/4. Good. Let's see how to find those numbers here. Good. And remember, we said before you can find equivalent fraction, any number that will be used to multiply the denominator must be used to multiply what? The numerator. Or the same number must be used to multiply what? The denominator and numerator. Okay, good. Now the first one, let me write my solution for all. Okay. And then our illustration. Good. Let me put it here. Okay, good. Now, when we take the first one, we say 7 out of 8 is equivalent or equal to a certain number here. Okay, out of 40. Now, in order to solve this one, now you first have the complete fraction here, which is 7 out of what? 8. So 8 is equal to 40 and 7 is equal to what? Unknown number here. Then, since we know the denominator here and the denominator here, then we know before you can get equivalent fraction, we always multiply a certain number by both numerator and denominator in order to arrive another fraction that will be equal to that. Good. So the fact that we know the 8 and the 40, our work here will not be something difficult. So then you think about the multiples of 8 that will give you what? 40. Or what number do you think we multiply by the 8 that give us what? 40. So here we multiply 8 by 5 and we said any number when you multiply by the denominator must be used to multiply what? The numerator. Okay, and then the same 5 must be used to multiply what? The numerator. And then 7 times 5 will be what? 35 here. Okay, all over the 4 times 5, that will give us what? 40. Okay, therefore our question mark here is what? Is 35. Okay, because when you put 35 at where the question mark is, it will make 35 over what? 40, which is the what? Equal to 7 out of what? 8. And that one will be equal or will be equivalent to that. Are you okay? Good. So that is how. So first you check the denominators or you check the common number that appears here. Now we have the 8 against the 40. And we always know that before you can get equivalent, it means both numerator and denominator has been multiplied by a certain number in order to ascertain another fraction that is also having different numerator and different denominator. Okay, now when you cancel 35 and the 40, if you still doubt, we have the 35 here over 40. If you still want to cancel them, okay, good. 5 goes into 35 is 7, and 5 goes into 40, and that is 8. Therefore, the common fraction here is 7 out of what? 8, which means that which means that 7 out of 8 is equivalent to 35 out of 40. Okay, so the question mark here is what? Here is 35. Okay, good. Now let's work the second one. Now the question says what? 4 out of 5 or 4 over 5 is equivalent to a certain number here out of 20. Okay, but we all know before you can get equivalent, there's a same number used to multiply the numerator and then the denominator. So once we know the denominator here is 5 and the denominator of the other side is 20, which means that there's a number used to multiply the 5 here. That's why we're able to get a 20. Okay, therefore you do your statistics here. 4 out of 5. Then you think about the number that we multiply by the 5, that will be equal to the 20 because they have the same denominator, okay, and the same numerator. Now, when you multiply the 5 by 4, then you'll be what? That one will be what? That one will be 20 here, okay? Good. And because we know the principles of getting the equivalent fraction is that the number used to multiply one of the numerator or the denominator must be used to multiply both numerator or denominator here. So once you have gotten the 4 to multiply the 5 to get this, the same 4 must be used to multiply the numerator here. Okay, therefore 4 times 4 is what? 16. Okay, so which means that our question mark here is what? Is 16. Are you okay? Good. If you're still doubting, then you want to cancel the 16 out of 20. Okay, whether you can still get 4 out of 5, then you cancel. 4 goes here, 4 goes here, then that is what? 5. Therefore, 4 over 16 can also be reduced to 4. 16 over 20 can also be reduced to what? 4 out of what? 5. Okay, so which means that here the question mark here is what? Is 4, is 16 rather. Okay, because when you multiply, you got a 16 out of 20. So here is what? 16. Okay, good. Now we said for this question here, the last one, which is a question mark here over 24 is equal to 3 over 4. Okay, and we said before you can get equivalent fractions, we use counting numbers to multiply the given fractions, and then we arrive at another fraction that will be the same, and the number that will be used to multiply the denominator must be used to multiply the numerator as well. So here, it's good that we're able to identify that we have the denominator here, 24, and then another denominator here is what? 4. And equivalent, they are the same. So what number do you think when you multiply by the 4 here, that gave you 24? Okay, good. Then let's work this one out. Now you take your 3 out of 4. Then you think about the number when you multiply by the 4. That will be what? 24. Okay, so that number will be what? 6. Okay, so the same number must be used to multiply what? The numerator. Okay, and that is the 6. Always the number used to multiply the denominator must be the same number used to multiply the numerator. And let's check this one here. So when you multiply the numerator, 3 6 what? Which is the 18 out of 24. Okay, good. Now we have 18 out of 24, and the 18 out of 24 is equivalent to 3 out of what? 4. So which means that here, the question mark here is what? 18. Okay, good, it's 18. Therefore, if you're still doubting, you can also reduce the 18 and 24 into 2. Okay, good. Now, when you have the 18 out of 24, if you want to cancel them, you can choose a number, any common number. You can either start with a 2, 2 goes here, 9, and 2 goes here, that is 12. You can still cancel this one here. 3 goes into 9, that is 3. 3 goes into 12, that is 4. Therefore, this one you can cancel again, so the final answer is 3 out of what? 4, which is the same as 3 out of 4 here. So that is how equivalent fractions looks. So always you choose a counting number starting from the 2 to write another equivalent, or you check the denominators and then you choose a number when you use to multiply the one side, which is the complete fractions, to get the other side, which is uncompleted. Therefore, we use the same number to multiply the numerator before you can draw your conclusion. Okay, good. Thank you for watching. See you later. Bye.